Right, so we were doing something called copy and write collections. All right, now copy and write collections and copy and write sets are, this is a copy, or this is a thread safe array list, and this is a thread safe set. Okay, now if you remember before about, am I recording? Okay, now, so if you remember about array lists, what happens is they're not very efficient at all right? Because every time, so once, so up to the size of a 12, an array list is fine, okay? Once you go beyond the size of 12 with an array list, so if I add, let's say we have an array list of 10 items in it. If I add something to it, now there is an array behind every list, there is an array, okay? Behind every list, there is an array list in particular. So if you have up to size 12, so we add one element to this, okay? So you then have 11 items in the array list, okay? The array that's behind that, it's still the same array. Now, however, when you get to 12 items in an array list, isn't it 12, isn't it, I think? Is it 10? Yeah. Sure? 16 for that, 10 for an array list. Okay. Now, so what happens with an array list after 10 is that every item you add to it, what happens is that there's a new array created in the background. Okay. So there's a new array created in the background. So there's a new list effectively assigned to the reference each time. So that one is a different array to that one, and that one. So if you go from 10 to 1,010,000, that means there's been 1,000,000 arrays created in the background. Yes? Right. Now, this can lead to problems. All right. The first thing is that of all the collection-based objects, array lists and sets are the two most unthread safe. Would be such a word. Okay. If you are going to use collections, right, and you don't want to use one of the thread safe classes, the ones you should definitely not use is an array list or a set. One of the reasons I'm going to show you is here. Now, so I create a list of strings, and it's got Noel, Tom, Mary, Shelley, Laura, Jack. Okay. I declare an iterator. Now, an iterator is just an object you use to go through a list. That's all it is. Okay. Now, an iterator is always based on a collection object. So I created an iterator called my iter. Okay. And what is it? It's an iterator for this guy. Okay. That's what it's for. Now, while my iter dot has next, all that this is going to do, this is just going to go through the list. Okay, it's using this object, okay, which is based on this list, so it will be used to iterate over this list. Okay, that's what it will be done. So while my iter dot has next, now that object starts just before the word null. So what you're saying, has next returns true or false. So it's saying is there going to be, so just at the very start, is there a next one? Yes, there is. So then I go my iter dot next. That is going to be the word null. While my iter dot next, is there a string after null? Yes, there is. So the dot next brings us on to Tom. We ask the question, is there a string after Tom? Yes, there is. So my iter dot next brings us on to Mary. We ask the question, is there a string after Mary? Yes, there is. So then we go on to the next value, which is Shelley. We ask, is there a string after Shelley? That's the has next part. Yes, there is. So the next part brings us on to Laura. Is there a string after Laura? Yes, there is. So that next part brings us on to Jack. While my iter.has next, there's nothing after next, so that'll be false. So all that does is just iterates through the list of names. Yes? That's all it's doing. All right. Now, iterators only go one way. All right. Can't go backwards. So at the very end of this loop here, the iterator is right here. It's at the end of Jack. All right. So if I go here while my iter.has next, that's going to print off nothing because there's nothing after Jack. Okay. So iterators are all about the position you are inside your collection object. Okay. Now, a list iterator can go both ways. Okay. Your man's got a real evil sounding laugh, doesn't he? He sounds like a witch or something. Sorry. System.out.println list iterator. Right, so now if I wanted my iterator to work again, you'd have to redefine it again. You'd have to do something like that. Okay, now the alternative is to use a list iterator. What is a list iterator? A list iterator can go forwards and backwards. Okay, so same as an iterator, it's my list iter, so it's going to be based on the list. So it's going to be based on the list. Okay, so this is a list iterator for that guy there. So it can go forwards and it can go backwards. So same thing here. So the has next operates the exact same as this guy up here. Okay. Now, so at the end of that, we're now at the very end of our list. However, this is a list iterator, so we can use has previous. So it starts at the very finish and it asks, is there a string before the finish of our list? There is. It's the string Jack. So then my list iter.previous is going to be Jack. Is there a string before Jack? Yes, there is. It's going to be Laura. So my list iter.previous is going to get Laura. Is there a string before Laura? Yes, there is. Shelley. So then my list iter.previous is going to get us Shelley. Is there a string before Shelley? Yes, there is. Mary. So then my list iter.previous is going to get Mary. Is there a string before Mary? Yes, there is. Tom. My list.previous is going to get Tom. Is there a string before Tom? Yes, there is. Noel. So my list iter.previous is going to get Noel. Is there a string before Noel? No, there isn't. So this guy here, we're now back at the very start. Okay, does everyone understand that so far? Yeah? Now, why am I showing you all these iterator things? The reason I'm showing you them is that if you have an iterator that's based on a list or a set that's not thread safe, then the iterator itself is not safe. All right? Now, if something is not thread safe, I'll show you what happens. Okay? So, I created, so this, I'll just write out my list here so we can see what's in it. So, it has the words Noel, Tom, Mary, Shelley, Laura, and Jack. Okay, 1, 2, 3, 4, 5, 6, 7. Okay, there's our 7 strings. All right. Now, I come along here and I create an iterator on this list. Okay, so if we did while my iter dot has next, and I go my iter dot next, it would go through all the list. Yes? Now, however, if we do, so I'll just take out this guy. Now, I am going to change the list. What I'm going to do, I'm going to list.add. I'm just going to put in, who's a naughty little boy? Satan. Okay. I go to add the word Satan to my list. All right. Now, if I go while my iter dot has next, hold on a minute now, this is EX7, make sure I'm the right one. Right, now, see what we get. Okay, I have an iterator that is based on this list. Now, if we change the list in any way, okay, this list, this iterator is based on the wrong list. Okay, now I have added Satan to the list. So then my iter dot has next, it's not iterating. This is a different list. Okay, and this iterator can only iterate over this list. So if we change it in any way, you're going to get concurrent modification exception. If you get concurrent modification exception, that means that the list is not thread safe. That means that the iterator is also not safe. Okay, so array list is not safe. So if you change your list in any way, you add an element to it, if you remove an element to it, it's going to give you concurrent modification exception. Yeah?
Just so that you get the error, you're saying that the thread is not safe.
No. It's not the thread is not safe. Is that you can see that the list is not thread safe. Okay, and if you base an iterator on a non-thread safe list, it means the iterator is not thread safe. Stands to reason. Okay. Now, if I try to add something to it, it's going to give us a concurrent modification exception. If I try to remove something for it, so I want to remove Tom. I get a concurrent modification exception. Is everyone with me so far? Yes? Yeah? So if you add or if you remove anything to the list, it's going to give you an error. If I assign a new list to it, now I can't forget whether this happens or not. So if I assign a new list to it, go list is equal to new array list arrays dot as list, and I'm just going to put in the words str str 3 times. Now see what happens. Let me see if that's right. So if I try to assign a new list to it, it won't give you a concurrent modification exception. It will access the old list. Okay, now I'm not 100% sure why it does that. All right, if you add anything to the list, it's going to give you a concurrent modification exception. If you take anything away from the list, you're going to get a concurrent modification exception. If you assign your list to a new object, the iterator is then going to iterate over the old list. Now, I'm not 100% sure why it does that. Okay? I'm sure there is some valid reason why it does that, but I'm not 100% sure why it does that. Now, that's not a very satisfactory explanation, I know, but that's the best I can do at the moment. Okay? So this guy does not cause a concurrent modification exception. It causes this iterator to be iterated over the old list. Okay? So put in here, if you add any item to the list and then try to use this iterator to iterate over the list, you will get a concurrent modification exception, as this list is not thread safe. So the iterator is not thread safe. Okay, and this one here, if you remove any item from the list and then try to use this iterator, you also get a concurrent modification exception. Okay, as not thread safe. Now, this one here, this will not cause a concurrent modification exception. This will cause the iterator to iterate over the old list, which contained the strings which we have here, these guys. Now, so I don't know why it does that. I'm sure there is some good valid reason, but as far as I know, that's not examinable. All right, I'm not too sure why it does that, but it does. Okay. Now, also, I'm going to change my list back to its original state again. So there's my list back to its original state. It's got Noel, Tom, Mary, Shelley, Laura, Jack. Okay, now, if I go for an enhanced loop, now I go now, if you could add strings by using an enhanced for loop, you can't use it with the for loop. All right. Now, you can use certain circumstances with an enhanced for loop. This is one of the circumstances where you can't add or remove to a list. Okay. Now, if you could add this string to this list, what you would end up with is you have 7 strings there, and you would have 7 new string words there as well. Okay, so it would input that for every string we have there. So you'd end up with Noel, Tom, Mary, Shelley, Laura, Jack, new string, new string, new string, new string, new string, new string. You'd end up with 6 new strings. Okay. However, when I run it, we get a concurrent modification exception. Why? Because list, it's, now this is, believe it or not, this is an iterator. Okay. This is an iterator. This is the list. That's not thread safe. So the iterator for the list is also not thread safe. Okay, so put it here. This also produces a concurrent modification exception, as list is still not thread safe. Still not thread safe. Okay. And you can't use an enhanced for loop, or you can't use an iterator to add something to a you can't add something to a list with an enhanced for loop or an iterator. You can't take anything away from a list because it's not thread safe. Okay, this will also produce a concurrent modification exception as it's not thread safe. So we're going to have in its place is we're not going to have an array list. We're going to have this guy. Okay, so this is the guy we're going to be using. So I have list integer. I call it copy list is equal to new copy on write array list. Okay, and I've just got 4 numbers in it. Right, so I'm just going to put in here, copy list. Right, so now I am going to go here for integer I. I'm going to use that to go through copy list. Now I'm going to go copy list dot add, and I'm going to add the number 99. And we're also going to print out the number. Now, so what we're going to try and do is, we hope here, is that 4352. So that should mean that 99 is also inserted into the list 3 times. Okay? So I am going to print this out. Now, so we can see that has printed off 4, 3, and 52. So it looks like nothing has happened. But if I print off copy list down here, we'll see that it has. Okay. Now, as you're adding something to a copy and write array list, you can't see it. Okay. Also, if you're removing from a copy list, you can't see what's been removed. All right, because that is still iterating over the original list, which was 4, 3, and 52. Okay, because I'll say that again. This guy is iterating over the existing list of 4, 3, and 52. It's only after it's done its iteration does it do that. Is the best way to describe it. Okay, copy and write array list. All right, so you won't see the changes. Okay, if you print it off inside here, it'll only print off 4, 3, and 52. However, it has changed copy list. It has added 3 numbers to it: 99, 99, and 99. Okay, so I'll put it in here. That's the rule here. So by using a thread safe, this guy, copy and write array list, really rolls off the tongue. You can remove, you can add and remove objects from the list. So here, for every number in this list, we will add a number 99. So the number 99 will be added 3 times. However, you will not be able to see the changes in the loop. It's only after the loop we will see that 99 has been added 3 times to the loop. So in effect, this iterator is still only iterating through the original list. Okay, what this is actually doing is copy list add. That is doing it after it has gone through the list. So copy and write array list goes through the list. Now, what happens in the background is that a brand new list is created there. Okay, so a brand new list is created with 4, 3, and 52 in it. And then the numbers are added to it 3 times. So the iterator is still only going through those 3 numbers. Now I'm going to show you with an iterator. Now I'll try it with a remove. I don't know if it'll work too well with remove. So if I go for integer, I copy list. If copy list dot, let's see, if copy list, so if I equals 99, copy list dot remove I. Now I think that'll work. Yeah. All right, so to prove that it's been removed, let's have a look. 4, 3, and 52. Now, believe it or not, a stream is much easier using that. You go stream dot filter, and you would say the number 99. Okay, so we can see here, we can remove from the list, okay, if the number is 99, this will be removed from the list. Okay, now if I'm inside the list, I'm going to say I. Okay, we can see that 4, 3, 52, 99, 99, 99. Okay, so it doesn't see inside the loop that 99 has been removed. Okay, because this is thread safe. So what's effectively happening is that it will go through all of the list first. Okay, it'll use this guy here to go through the list first. And it's only at that point then will it consider removing anything. And what does it remove? It removes the 99. Okay, so it prints off 99 and then it removes it. That's actually what's happening. Okay, sorry?
When you read,
Yeah.
if you didn't do that, you'd have the infinite, you know, that list will be continually extended.
Well, no, but you see, it's only going to go for the length of that, which is 3 times.
Yeah,
So-
but if you're keeping the same, if you're changing the original list to be 99, then it has to go to 4 to 99. So that means that
Well, no, because, right, so integer I copy list, okay? That means that this loop is only going to go 1, 2, 3 times. Okay, what's going to happen 3 times? It's going to add the number 99 3 times. That's it. But because the iterator is tied to the original list, it'll only print off 4, 3, and 52. However, though, as soon as you come outside the loop, you'll see that this now has 4, 3, 52, 99, 99, 99. Okay, whereas this one down here, we're doing the opposite. Integer I copy lists. So it goes through the loop. 4, 3, 52, 99, 99, 99. Okay, so it's only at that point then does it remove it. So there's threads going on there. There's actually 2 threads going through that guy there. Okay, so that's proving. So now we now have a list with 4, 3, and 52. Okay, now if I use iterators, so I'm going to use an iterator down here. So I am going to go, I'm going to create another iterator, an integer iterator, and I'm going to call it copy iter is equal to copy list dot iterator. Now, so I'm going to go along here and I'm going to add something to the list. So I'm going to go copy list dot add. I'm going to add the number 1000. Now, if this was a non-thread safe list, it wouldn't iterate through it. It would give an error. Okay, so I'm going to do this while copy iter dot has next. I'm going to go. I'm going to make it a print statement rather than a print lin. Okay, system dot print. Okay, I'm going to put in here. I'm going to put in copy iter dot next. Right. So I added 1,000 to it. Now, previously, if you add something to a list, the iterator won't work. Okay. However, this is a thread safe list. This is a thread safe iterator. So it does work. However, it iterates over the original list. It does not iterate over the new list. Do you understand that? So to prove that our list is now different, we can see, okay, copy list. There's our new list. Okay, so iterators, if you add something to a thread safe on copy and write array list, okay, they will work, but they'll work on the original list, not on the newly modified list. Okay, so this code will run, but this iterator is still based on the original list of 4, 3, 52, and will not display the number 1000, even though copy list now has this number in it. Okay, so what does this display? It displays that, and whereas this guy displays this. Now, all that sort of shit and shenanigans says to me they're definitely going to be on the exam. All right, so all that shit and shenanigans means they're definitely going to the exam. Now, the upshot of all of these is don't use these things. Simple as that. Okay, I wouldn't advise you to use them. Now, there's a couple of reasons why you shouldn't use them.
Don't use what no.
Copy and write, what is it called again? Copy and write array list. Number one is because there's a fair few things you have to think of. Number two, well, the main reason you don't use them is that they're extremely memory intensive. All right, there's a lot of things happening there. The whole idea of threads is to make your code run faster. If you're using these guys willy-nilly all over the place, they're very memory intensive. They're more memory intensive than array lists, actually, as far as I know. Okay, so these guys are intensive. Now, what does it say when you should use them? Let me see now. I have it written down here somewhere when to use them. Now, so these guys, I have a comment here. Now, I'd advise you not to use them at all, to be perfectly honest. All right, I'd use any of what you usually normally do is inside your thread, you're going to be using all normal collection objects. It's only if you want a collection object to be shared outside of that thread, then you have to use a concurrent. There's a couple of ways of doing it. You can have a synchronized method, you can have a synchronized block, or you can have one of these concurrent classes. You just copy it into one of these concurrent sets or maps or whatever. All right, I wouldn't be too mad about using this one though. Okay, now where does it say to use them? I have a comment here. This is my comment. So the copyright classes can use a lot of memory since new collection structures need to be allocated anytime the collection is modified. So you're adding something to it, just like an array list, but there's even more going on than an array list. So they're commonly used in multi-threaded environment where reads are more common than writes. So if you're just reading from it, then these guys are all right to use. It's only when you're adding and you're removing things, that's when they start to become intensive. If you're just reading from an array list is fine, because all you're doing is just reading from the list. If you're adding numbers to an array list, that's when the memory performance starts to suffer. The exact same thing with these guys. All right, they're a thread-safe version of an array list, a thread-safe version of a set. Okay, I'm not going to bother doing a set because it's the same rules. If you're just accessing the copy and write array list, then they're fine. It's when you start adding things and removing things to it, that's when it starts to be memory intensive. Okay, now the final option you can have for concurrent classes, which I would recommend you not using it. All right, it's the following. So this is going to be static void ex8. Now, so what are these guys? These are, now I don't know why you'd use these, but who knows? So synchronized versions of existing, non-concordant collections. Now, it's very easy to create, let's say, if I want to create a new copy and write array list from a list, let me just show you how I do it. So for instance here, I'm going to create a list of numbers. I'm going to call it list. And I'm going to create from a stream. Stream.generate. So generate takes a supplier. So we're going to go int map.random multiply by 100. And we're going to limit it to 10. 10. Limit it to 10. And then we're going to go collect collectors to list. That's a list of 10 numbers. Okay. And a very easy way to convert from a list to a thread set list is, okay, take it out here. There we are. That's the simplest way to convert from a non-thread type, a non-thread safe type to a thread safe type. Okay. Now, this is an alternative. I don't know why they're showing this alternative, because it's not fucking easy. All right. So this is an easy way to convert a non-thread safe collection type to a thread safe collection type. So you can imagine a situation, you're inside a thread, you're doing all your calculations, and at the very end of it, inside your one thread, you're producing this list, and you want to share it with other threads, so you want to make it thread safe. All you have to do is that. Does everyone with me so far? Yes? So it's relatively easy to create a thread safe version, a thread safe collection object from a non-thread safe collection object. All right. All you do is just put it there in the parameter list. Okay. Each of the collection classes can take another collection object to create itself. Remember that. So each of the collection classes can take any other collection.
Richard Watkins, please contact reception. Richard Watkins, please contact reception.
Any collection object can take another collection object to create itself. So you can see here, this is a copy on write array list object, and it's being created by using the array list object called list. Okay. Now, so there is another way to get, so we want to see what list looks like. Okay, EX8. Okay, so there's our numbers. Now it's not a set, so they're not organized. Okay, so, and we've got naught in there. All right, so how would I get rid of naught? How would I go from 1 to 100? Yep. So if you want to make sure it's going to be int math random multiplied by 100, plus 1. Okay. So int math.random plus 1. So if it produces a 0, it's going to be now, because math.random multiplied by 100 is never going to give you 100. Okay. It'll give you 99.999999. But if you int it, it's going to become 99. So if you add 1 into it, it'll become 100. Now, this could give you 0 because you can get math.random can produce 0.00 something. Okay? 0.00. It could produce 0.00 number or even 0.000 number. Okay, if it does, the multiply by 100 is just going to give you a 0. All right? Because, I'll explain that. So by using this, math.random, that produces a random number between 0 and 1. Now that number could be 0.01456, or it could be 0.4562. You multiply both of those numbers by 100, you will get 1.4 and 45.62. You cast them to be an integer, you're going to get 45 and 1. Okay? Now, if I go math.random, you could end up with 0.00432. Multiply that by 100, you get 0.432. You cast that to be an int, it's going to become 0. So if I want to avoid zeros, all you have to do is you just add 1 to it, and you'll get 1. The highest number you can get is 99. So if you wanted to get it between 1 and 100 inclusive, you just add 1 to it. All right, so there's going to be 10 numbers. All right, now this is the easiest way to convert it to a thread safe list, but there is another way of doing it. Okay, now the other way of doing it is the following. So I create a list, and I'm going to call it integer, and I'm going to call it sync list is equal to, you go collections dot synchronized list, and I quite simply go list. Now, so what does this do? So this returns a synchronized version of the list, array list. So this synchronize, here's the problem with this one. Only this synchronizes the get and the set methods of this object. Okay, so only one thread can add an item to the list, to this list at a time, and only one thread can modify any item in this list at a time. Okay. However, the iterators are not synchronized. So I don't know why the Jesus you'd even use these things. So get and set is synchronized. Okay. However, so let's say I create an iterator based on integers. And I'm going to call it my iter is equal to sync list dot iterator. Now, if I add something to the list, sync list dot add, I'm going to add the number 1000. And I'm going to go while my iter dot has next. I'm going to go my iter dot next. Okay. This is not synchronized now, so that means I don't know why the Jesus would use these things at all. All right, I don't know the reason why you'd use them, because this guy here, that is fully synchronized. All of the methods are thread safe. But if you use this thing, synchronize list, the only methods that are synchronized are set and get. Do you understand what I'm saying? Okay, so only one thread at a time. So many threads can use the add method, which means that the add method is not thread safe. So you'd have to go to the kind of lunacy, what you'd actually have to do if you're going to use this guy. All right. So that's going to cause a concurrent modification exception. Okay. This causes concurrent modification exception. Okay. So if you want this guy to work, what you have to do is you have to go synchronized, and I'm going to use sync list itself, synchronize the block. So now if you do while my iter dot has next and my iter dot next shit, so I've done something wrong there. Okay, right. Even synchronizing it doesn't work. Fucking hell, let me see now. Okay, even synchronizing doesn't work. All right, let me just see now. Okay, I need to come back to that one. All right, because I have to do something called double synchronization, which is not on the exam, but I will come back to it. Simple fact is, don't use that guy. All right, it's pure bullshit. I can see absolutely no advantage of using that over something like that. Okay, because this only synchronizes the get and the set, doesn't synchronize anything else. So if you add anything to the list, it's going to be, now I think what you have to do is you have to add it inside here. Now that might work. Nope, still doesn't work. Okay, so I'm not too sure what I have to do there to get it to work. As far as I know, what you have to do is you have to do something crazy like you have to do a combination of getting and setting to add something to it, which you can do, but it's complicated as hell. All right, but all you really need to know for the exam is you can use this, yes, but only the get and the set are synchronized, not any other methods of the class. So it just doesn't work. All right, so if you're going to use a synchronized list, use one of these options up here. Okay, we went through a blast of them. All right, use one of those. Now, you wouldn't use them willy-nilly, you wouldn't use them all over the place. You'll only use them if, when you're inside one thread, let's say you have your 4 threads. Okay, you have your 4 threads. Do you remember the German guy was going on about services the other day? Remember? Well, there's a reason why they're all called services. Why do you think all those things in Microsoft are called services? Why? Because they run as a thread on your application. All right? So one of you could put up at your hand the last day. Is that a multi-threaded or a single-threaded application? He'd know. He'd fucking know, by the way. Well, I was afraid to say it as well for fear it was wrong. You know? Or because I didn't know enough to ask questions there sometimes. You can only ask questions if you know about what he's kind of generally talking about. So you have your 4 threads. And your 4 threads, so this is to do with your database. This is to do with your GUI. This is to do with your files. And this is to do with your user input. Now, your 4 threads. Now, inside each one of those threads, it operates as a single-threaded program. Do you understand that part? Yeah. So it's like there's 4 separate applications running at the same time. That's a multi-threaded application. It means that you have 4 applications basically running at the one time. You've got 4 stories being told at the wrong time, at the same time. You have 4 flows of control going through your program at the same time. Okay? Now, you only need to use thread-safe variables, be they collections, or be they synchronized methods or blocks or whatever, if the threads are communicating with each other. All right? The database, it can operate all the way through. However, you do some operation, it produces a list of members for our club that you want to display in your GUI. Okay, this is a different thread. So the list that's produced from this starts off as an ordinary list. You just copy it into either any one of the collection types that we have, probably a hash set if you want to be the unique. So I can't remember. Can I remember what's the name of a thread safe hash set? Didn't we do a thread safe hash set, didn't we? I don't know the names of these things. Mention some collection object. I don't want to make it a copy and write array list, something else. Is there any set of any description? Let me just have a look. So the first one we did was actually a hash map. I don't really want to produce a hash map. So we've got concurrent hash map, we've got a deck, concurrent linked queue, concurrent queue, concurrent skip list map, concurrent skip list set. So I am going to say a linked blocking deck, for instance. Okay, so this guy produces a list. I can produce a linked blocking deck by putting it into the parameter list. How would you do that? You would go like this. So let's say I produce a list of properties, our list of members. And this is called members. It's an ordinary list. And so inside here, I would go blocking deck, and we'll say string, and I'll call it block D is equal to new blocking deck, and you go like that, and then here you would put in members. Okay, and then you could share that with other threads. All right, and then other threads could access that, and you only know one thread's going to access it at a time. So you don't have to make all your variables either synchronized, or you don't have to make all your collections synchronized. It's only the things that's going to communicate it between the different threads. They either have to be synchronized, either synchronized method, synchronized block, a synchronized variable, or a synchronized collection, or one of these thread safe collections. All right, so do you have to synchronize all your variables? No. Should you synchronize all your variables? No. Only the variables that are going to be shared across your threads. And you want to make sure only one thread accesses them at a time. If you are okay, by the way, with multiple threads accessing the one collection or accessing the one variable at the same time, then you don't need to synchronize them. We're going to be showing you why you would need to do that. Now, it could be tomorrow before I show it to you. All right? So it's only variables that are shared across threads that have to be either A, synchronized, in a synchronized block, be synchronized, B, what's the variable type you can have that's not synchronized? What did I call it again? Synchronizing data access. Hold on a second. So atomic. Okay, so you can either have an atomic reference, you can have a synchronized block, you can have a synchronized method, or you can use one of the collection, thread-safe collection objects. So there's your 4 options. All right, you can make your variable atomic. Now anything can be an atomic, by the way. So you can have an atomic, as we have them here. So you can have atomic integers, you can have atomic arrays, you can have atomic longs. You can have an atomic reference. Okay, you can have an atomic reference. You can have a synchronized block of code. You can have a synchronized method. Or if you're using collections, you can use one of the thread-safe collection classes, which are concurrent hash maps, concurrent linked deck, concurrent linked queue, concurrent skip list map, concurrent skip list set, copy and write array list, copy and write set, linked blocking deck, linked blocking queue. It's up to yourself which one of those you want to use. If you are going to use copy and write array list, as long as you're only reading from a list, you're not changing items in a list, then you can use that. If you're going to be changing items in the list, it's not advisable to use that, particularly if it's a big list. There's nothing wrong with it in itself. It's just going to lead to a huge memory load on your machine. Okay. Now, so that is that section finished. Okay. Now, so the next section we're going to do is working with parallel streams. So I just need to copy this piece of code here. I just need to put this at the very top. Now, so don't need that. So I am going to stop that video.